So, hello friends. Today we will discuss about the three problems actually. The relation between excess pressure inside the liquid drop or air bubble, excess pressure inside the soft bubble, and the excess pressure across the curved surface. Okay, so let's see first one, the excess pressure inside the liquid drop or air bubble. This is our first problem, liquid drop or air bubbles. Basically these are, you can think in problematic way, these two are same things. These two are same things. What are the liquid drop and the air bubble? Both are same thing. Let's see, this is a bucket which contains some liquids. Inside this liquid a air bubble is present. Okay, so pressure P1 is the pressure inside this air bubble and the P2 is the pressure of the liquid. So P1 is always greater than P2. Okay, P1 is always greater than P2. The pressure difference between this P1 minus P2 is known as the excess pressure, and this excess pressure is responsible for forming of that air bubble, because you can see the outside pressure P2 always try to shrink the air bubbles. Okay, but the difference between P1 and P2, that the remaining pressure or excess pressure, is make the existence of this air bubble. So you can see this is a liquid drop present in a atmosphere. So P1 is the pressure inside the liquid drop and Pa is the atmospheric pressure. So the existence of liquid drop is only happen when the P1 is greater than Pa due to the surface tension. So why this P1 is always greater than Pa? This is due to the surface tension. You can see that why this P1 is greater than P2 by this example. This is a balloon. The pressure inside this balloon is P1 and the outside the pressure is the atmospheric pressure Pa. Suppose you just open this balloon by this end, what happens? The pressure comes, air comes from inside air of balloon comes to outside. You know that air always moves from higher pressure to lower pressure, so that's why the P1 is greater than Pa, and this difference between this inside pressure and the outside pressure is known as excess pressure, and we will see today what is the relation between this excess pressure and this surface tension. Okay, the first one is our liquid drop or air bubble. Yes, another things why I take one first problem as the liquid drop and same as air bubble. You can see in this air bubble only the inner surface is contact with this air. What? Now the inner surface is only contact with air, but outer surface is contact with liquid. You can see this liquid drop. In liquid drop present in a surface in atmosphere, you can see inside this sphere only liquid is present, but outer surface is only contact with this air. So how many surface contact with air here? Only one. This for the liquid drop is outer surface, for the air bubble present inside a liquid is inner surface. So for the both case only one surface is contact with air. This is a same type of problem, liquid drop or air bubble. But we'll see next that the soft bubble or if I say in Oriya that the soft phenom, this is another kind of problem. Okay, second type of problem for us. So let's move to the relation between the excess pressure and the surface. Take a example of liquid drop or air bubble. I will pronounce it only one, that liquid drop. Take a liquid drop of radius r. P1 is the pressure inside the liquid drop and Pa is the atmospheric pressure. The excess pressure is the difference between inside pressure and the atmospheric pressure, that P is P1 minus Pa. Suppose this pressure suppose what happened that suddenly that something is happened, that pressure is increases from P to dP. I represent so this the excess pressure is increases P to dP. So that what happen, if the pressure is increases, thus the liquid drop start to expand. When it expand, its size is increases. Okay, you can see my cursor, the size is increases. Okay, so next what happen, let's draw this bigger size liquid drop is here, that this is the after expansion of this liquid drop due to the increase of the pressure from P to dP. Okay, and what happened, the radius is also increases from R to dr. You can see here those molecule present before expansion on the surface of this liquid drop is displaced by the distance dr due to the expansion. Since the molecule displaced, there is some work done happening due to the there is some work is done. Okay, so this the expression of work done is force into distance, we know. So you can see here the displacement is the radially, because the expansion is radially expansion. The smaller liquid drop is expand radially, okay, symmetrically, so that this is in radial direction from center to outward, and the force is also outward. So angle between force and the radius is 0. Now you can see this force, so F dot dr become F dr cos theta. Cos theta is here 0 because the angle between F and dr is same. So cos theta is 1, sorry, cos 0 is 1, then this is F dr. So F dr. So you can see, we know that force is equal to pressure into area. Pressure is for this P, excess pressure, into area is 4 pi r square into dr. So what is the increment is area when the smaller liquid drop expand to a larger liquid drop due to the increase in excess pressure. So increment in area is equal to 4 pi r plus dr whole square minus 4 pi r square. The surface area of larger sphere minus surface area of the smaller sphere. This smaller sphere radius is r, and the larger sphere radius is r plus dr. So this is 4 pi r plus dr whole square minus 4 pi r square. When we expand this term r plus dr whole square, this is 4 pi r square 4 pi dr whole square 4 pi r dr minus 4 pi r square. So 4 pi r square is cancelled out. If the dr is very small, dr square is very small. You can see here a small example. If the 0.5 is small, 0.5 the whole square is 0.25, which is less than 0.5. So we can negligible this dr square term. So the increment in surface area become 4 pi r dr when the liquid drop is expanded to larger liquid drop due to the increase in excess pressure. The increment in surface area is 8 pi r plus dr. Okay, so then when the surface area is increases, then potential energy is also increases for that liquid drop. The increment in the potential energy is equal to surface tension into increment is area. Why you can see that we know that surface tension is increment in surface energy per unit area. Increment in surface energy per unit area into increase in area, that is the total increment in potential energy for unit area. If the surface some energy increases into that total increment, it will give the increment in potential energy. So this S is the surface tension and 8 pi r dr is the our increment in area. Oh, I will just replace S with T for our simplicity in our convenient notation in physics. So now I write it 8T pi R dr. For simplicity, let the system is adiabatic process. There is no heat energies there is no heat energy exchange between this lower during the formation of the larger sphere, liquid or sphere from the initial one. Okay, so heat energy is constant. Then with this adiabatic condition system, work done is equal to increment in potential energy. So what is the value of work done? The value of work done is equal to P into 4 pi r square dr. We work done what we derived before, P 4 pi r square dr in is equal to increment its potential energy value is 8T pi r dr. Now dr cancel, r square power 2 cancel, then pi cancel. Here is remain P 4, here remain 8T. So now P is equal to 8T by 4R. So this P is equal to 2T by R. This is the relation between excess pressure and the tension, surface tension, not tension. Okay, this is the surface tension for a liquid drop or air bubble. Okay, thank you. We'll see the next problem that is solvable in next video.